Let's first review the conditions for rigid body equilibrium. For a rigid body to be in equilibrium, there are two vector equations that need to be satisfied. The resultant force acting on the body needs to be zero, and the resultant moment summarized about any point needs to be zero as well. Or we can write scalar equations instead. For 2D problems, there are a maximum of 3 scalar equations enabling us to solve for 3 unknowns. And for 3D problems, there are a maximum of 6 scalar equations enabling us to solve for 6 unknowns. So again, in order to complete the free body diagram, we need to identify all the external forces and couple moments acting on the body, and therefore we need to identify all the support reactions first. Once again, the rule of thumb is, if the support prevents the translational motion in a certain direction, then the support exerts a force along that direction against the motion. And if the support prevents a rotational motion about an axis, then it exerts a couple moment about that axis against the tentative rotation. Let's look at this example. We are asked to determine the support reactions at the fixed support point A. When we analyze the situation, we realize that since this is a fixed support at point A, it prevents all kinds of motion. Therefore, there must be force support reactions along all 3 axes and moment support reactions about all 3 axes as well. Let's first try to solve this problem using the vector formulation and represent the support reactions at point A as vectors, force vector Fa and couple moment vector Ma, currently in arbitrary directions. And the 2 applied forces can be expressed as vectors as well. Therefore, the resultant force equals to Fa plus 320J minus 240K and plus 200I, or in the unit of pound, and it equals to 0. Therefore, the force vector Fa is solved to be negative 200I minus 320J plus 240K pounds. To summarize the resultant moment, once again, you can do it about any arbitrary point, but you want to do it in a way to eliminate the most unknowns in your equations. Therefore, here we summarize the resultant moment about point A, since force Fa has a line of action passing through point A and therefore creates no moment about point A and will not show up in your equations. So, to summarize the moment about point A in vector formulation, we need to first find the position vectors from point A to, again, any point on the lines of action of the 2 applied forces. You can do it a million ways, but these are probably the best since they are the easiest. And now, the resultant Ma equals to the support couple moment reaction at point A plus the moment caused by the first applied force plus the moment caused by the second applied force. And that's all the external moments. From the calculation, the couple moment vector Ma equals to 1400I plus 480J plus 1840K in the unit of pound-foot. And of course, alternatively, we can solve this problem using scalar formulation. Now, at point A, we have overall 6 scalar unknowns, 3 forces along x, y, and z axes, and 3 couple moments about these 3 axes as well. Now we summarize the forces in each direction and solve for the 3 force components. And we summarize the resultant moment about each axis and solve for the 3 moment components. And as you can see, the vector formulation and the scalar formulation yield the same results. And it is your own preference which method to choose. Now, let's look at several types of bearings. First one is a single journal bearing. Let's analyze the reactions. Because the bearing prevents translational motions in these 2 radial directions, and only allows movement along the axial direction, And also, it prevents any rotation except for the rotation about the central axis of the shaft. Therefore, this single journal bearing exerts force support reactions along the x and z direction and moment supports about the x and z axis as well. The next one is a single thrust bearing. As you can see, this looks just like the previous one except for the thrusts, which now prevents the translational motion along the axial direction. Therefore, now this bearing also exerts a force reaction along the y direction. And lastly, let's look at the single journal bearing with a square shaft. And again, it looks similar to the first bearing, but now it has a square shaft which won't rotate. Therefore, when compared to the single bearing with a circular shaft in the first image, this one exerts an additional couple moment about the y-axis. Please note, if these bearings are used in series or in combination with other supports, then the couple moment support reactions might not need to be considered. Just consider the force reactions. Lastly, let's look at another example with a ball and socket support. Ball and socket support allows rotation about all axes but prevents translational motions along all three directions. And therefore, it exerts force reactions in all three directions but no moment reaction. Actually, the joints at our shoulders can be considered as ball and socket supports. And we know that the roller support exerts a force reaction only perpendicular to the contacting surface. And since this journal bearing is used in combination with the other supports, it only exerts force reactions along the y and z axis. Therefore, we note all forces and moments acting on the number, and we have 6 unknowns. And we write the 6 scalar equations for equilibrium, summarizing forces in 3 directions and moments about the 3 axes, everything equals to 0. 6 equations, 6 unknowns. We can now solve for all of them.